It's been my experience that they do not greatly change the types of questions on the AP test, which doesn't mean, oh, I can just memorize the kinds of, they're too hard for that. But the practice question, well, they're not practice questions. These were questions that were on AP tests in the past. But like I said, they don't change greatly. So really, a question from 2004, a question from 1994, a question from 1974, they're all going to look a lot alike. Now, in more recent years, they've incorporated the graphing calculator, but they did in 2004 as well. Okay? So if you can ever get a hold of a set, and all you got to do is go to the College Board website and get a hold of a set of old free response questions, the ones you're going to face this year aren't going to look tremendously different. Okay? You don't know exactly what they're going to ask, how they're going to ask it, but, you know, studying an old question is just as good as studying a new question. Okay? So let's go over one together. So look at number one here. Traffic flow is defined as the rate. Rate mean anything to you? At which cars pass through an intersection measured in cars per minute. So they're telling you that it's a rate again when they tell you cars per minute. The traffic flow at a particular intersection is modeled by the function capital F or capital F defined by. So, you know, sometimes instead of giving us a function to model it, might they give us a table of data? Yes. Okay. Could they give us both? They might. They might give you the table to work with for a couple of questions and then say, hey, here, use this model to answer this part. So that's what I mean by where they're all similar, but you can't just memorize because you never know how they're going to give you the information. All right, so capital F of t equals 82 plus the sine plus 4 times the sine of t over 2 for the interval from 0 to 30, where capital F of t is measured in cars per minute and t is measured in minutes. All right, now it's important to notice a graphing calculator, it doesn't say is allowed, does it? Is required for some problems or parts of problems. That doesn't mean every single part you use your calculator. It means some parts you won't be able to answer it without your calculator. Okay? All right, so part A. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? All right, so they're asking us to accumulate something, aren't they? The number of cars. So what should we be thinking? Integral, definite integral. All right, so we're trying to accumulate the number of cars over this period from 0 minutes to 30 minutes. So what kind of a definite interval are you thinking? Integral from 0 to 30. Of what? Of that function, of that rate. Okay? So we have the integral from 0 to 30 of capital F of t, which is 82 plus 4 times the sine of t over 2 dt. Punch that in on your calculator and take the integral of that from 0 to 30. Make sure you're in radians. If you're not in radian, you won't get the right answer. I do not have any spare batteries. I'll answer that in just a minute. I have an extra parenthesis. Oh, undo, undo. Is that what you guys got? Now, they do say to the nearest whole number. So, don't put the 3 digits to the right of the decimal like they tell us to do. They tell us, they preach it. And then what does the very first question say that we work together? Round to the nearest whole number. And I see why. You can't have 0.078 of a cost. All right. All right. Now, before we go on, somebody asked how many of each. It used to be 3 with the calculator, 3 without, and I've forgotten now. Is it 2 with and 4 without, or 4 with and 2 without? They changed it last year. It's 4 of one, 2 of the other. I'll have to look that up because I don't know. Okay? All right, part B. Is the traffic flow increasing or decreasing? At 7. All right. What do we need to know if a function's increasing or decreasing? The sign of its derivative. Okay? Now, we've got a calculator in our hands. So we don't have to, we can figure this out real quickly on the calculator. The rate of change, and technically it's the rate of change of the rate of change, but the rate of change of capital F is capital F prime of t. Well, don't we have capital F in our calculator? So this time, when we graph it, I don't know how to make that go away. I don't want an integral. I want a derivative. So let's do second calc. Let's choose derivative. And I want the derivative when x equals what? 7. And there it is. If the derivative is negative, is capital F increasing or decreasing? It's decreasing. Now, give a reason for your answer. So we got to say what I just said. Capital F prime of 7 equals negative 1.873. Since the derivative is negative at t equals 7, the traffic flow is decreasing at t equals 7 minutes. The minutes got chopped off, but I wrote 7 minutes, not 7 menu. All right. So unless we freeze up on the test, can we get A and B? We can get A and B. We know how to do those. Okay. All right. Let's see. Part C. What is the average value? Stop right there. Average value. Clue me in. What is it? 1 over b minus a times the integral from a to b of whatever it is you're finding the average value of. So in this case, look at the time intervals. So average value of the traffic flow of the time interval from 10 to 15. So it'll be 1 over 15 minus 10 times the integral from 10 to 15 of, all right, what was measuring the traffic flow? Capital F. So here's how we set this one up. Average value will be 1 over 15 minus 10 times the integral from 10 to 15 of capital F of t dt. Can we do this on our calculator? Yes, do it on your calculator. You've already got the function entered. The only thing you need to do different is change the limits of integration. So this time we'll do second calc, integral, lower limit is 10, enter, upper limit is 15, enter. We get that, but what do I need to do to that? Divide it by 5. Now, do I have to write down everything I've written down to get full credit for this problem? I don't think so. I don't think I have to put that, and I know I don't have to put that. Or I could put that and not that, couldn't I? I don't have to put them both. Now, you know me, I kind of got to put them both. But if time's an issue, maybe I don't. Okay? And the last one. They ask us, what is the average rate of change? Average rate of change, that's slope formula, isn't it? Of the traffic flow over the time interval from 10 to 15. So, it's the average rate will be the y coordinate, in this case the f coordinate at 15, minus the y coordinate at 10, because of the interval they gave, 10 to 15, so it's y2 minus y1. The value at 15 minus the value at 10, over x2 minus x1, 15 minus 10. Now, how can we find capital F of 15? We could trace, I'm going to use the table. I'm going to go second table, delete all that stuff out. I want x to equal 15. I get that. I want x to equal 10. I get that. Now all I've got to do is 85.752 minus 78.164, and then divide it by 5. From a table, I don't know. So, unless we choke, and look, I'm sorry to tell you, but choking is a factor. Unless you choke, can you get all 9 points for that question? Yes, you know how to do every single part of that question. In fact, we've done tons of those in the last couple of weeks, haven't we? Yes. So you kind of see where all this worksheets is taken. You are set for pre-responsibility. Or at least as set as it's possible to be. You really are. Okay?